dear learners. Today we are looking at the theorem 2 of our Circle Theorem. And the theorem 2 is saying that the angle a chord subtends at the center of the circle is twice the angle it subtends at the circumference of the circle. This is the theorem diagram. So let's look at the diagram. So what we are saying is that the angle a chord subtends at the center. So this is the center of the circle. This is the center of the circle. So the angle here is twice the angle here. What you must take note of this theorem is that the angle should be at the center. The chord should subtend an angle to the center. Okay, and then its corresponding angle is x. If that is the case, we are getting here to be x and then what? 2x. Now what it implies is that if this angle is 20, then this angle which is at the center is going to be 2 times the angle here to make it what? 40. But remember, the diagram can be drawn in any direction, so don't be confused. It's not static like this. It can be drawn in this very form, in this very direction. What you must take note is that the angle should be at the center. The chord should subtend an angle to the center, and then you have something like this. It can also be drawn in this very form. It can be drawn in any direction. You must have a geometrical eye to see this. Okay, it's not difficult. So we are going to look at the proof of the theorem, and then we look at few examples. So let's look at the proof. So this is the diagram of the theorem. Now with this very diagram, we can decide to draw a line from C to the center, which is what? O. So let's draw a line from C to O. Now you can all see that since O is the center of the circle, O to C becomes what? A radius. And OA also becomes what? A radius. And you know that radius, the length of radius are always the same. Therefore, the length of OA is equal to the length of what? OC. Now the length of OC is also the same as the length of what? OB. Now we can see that we are getting what we call an isosceles triangle, because we have two sides, and if two sides are equal, then their base angles too are equal. So you can say that triangle AOC and triangle BOC are all isosceles triangle. So if that is the case, then you can say that this angle is equal to this angle, and this angle, let's call this angle Y, is also equal to this base angle here. Now we have gotten triangle AOC. Now you know that the interior angle of a triangle is what? 180. So to get this very angle here, we can sum x plus x plus this very angle and then equate it to 180. Therefore, you can say that this angle is equal to 180 minus what? 2x. And this angle to y plus this very angle is equal to 360. Therefore, this very angle is also equal to 180 minus 2y. Good. Now let's call this angle theta. Let's call this angle theta. Now after getting this, we can use angle at a point. So using angle at a point, that is interior angle of a circle, angle at a point, sum of interior angle of a circle, that is angle at a point. So we can say that the whole of this angle plus this angle plus this angle is equal to 360, because the whole of this one is what? An angle at a point. Let me do it well so that you can see it well. So we are saying that this angle plus theta angle plus this angle, we are getting what? A circle. So when we sum them, we can equate it to what? 180. So we are going to get 180 minus 2x plus 180 minus 2y plus angle theta should give us what? 360. So we have 180 plus 180, we are getting 360 minus 2x minus 2y plus angle of theta is equal to 360. Now let's group like terms more. You can get minus 2y, x minus 2y plus the angle theta is equal to 360 minus what? 360. So we are getting minus 2x minus 2y plus angle theta is equal to what? 0. Now we can decide to bring 2x, minus 2x and minus 2y to this side of the equation. So we'll be left with theta is equal to 2x plus what? 2y. Now factorizing 2 out, we are left with what? X plus y. Good. So this is the proof. What is telling us that the angle theta, which is this very point, is x plus y times 2. Where is x plus y? This is what? The angle x plus y. So it means that when we have an angle here and then we multiply it by 2, we are getting this angle. And this proves or ascertains the theorem of 2, theorem 2, which says that the angle a chord subtends at the center of a circle is twice the angle it subtends at the circumference of the circle. So if this angle is, let's say, 40 degrees, this angle is going to be what? 2 and then what? Times 40, which is what? 80 degrees. So let's take examples. So we have the first example. Find the angle marked with letters if O is the center of the circle. So looking at this diagram, we can apply the theorem 2 to solve it. So looking at this diagram, you can see that this is the center, and we know that the angle here is twice the angle here. So if this angle is 60 degrees, this angle is going to be what? 60 times 2. Therefore, we can say that angle AOB is equal to 2 times what? 60. And that is giving us what? 120 degrees. Now the verse say we have to find x. Okay, so in finding x, now we know this angle to be what? 120. We can apply angle at a point so that we add x plus this very angle should give us what? 360. So we can say that using angle at a point, you can say that x plus angle AOB is equal to 360. But we know that angle AOB is 120 degrees, is equal to 360. Therefore, our S is equal to 360 minus 120, and our S is going to give us what? 240. Very, very simple. So from here is what? Theorem 2. Good. Now let's take the next example. So example 2, we have to find the value of y. To find the value of y. So you can see that we have an angle at the center and then we are having another at the circumference here. So it means that we can apply theorem 2 here, or theorem 2 will work here. But you can see that triangle AOB is what? Isosceles triangle. Therefore, angle OAB is the same as angle ABO, which is equal to what? 32 degrees. Because it is an isosceles triangle, the base angles are what? Equal. So this angle is also 32 degrees. Okay, now using the sum of interior angle of a triangle, we can get angle AOB. So 32 plus 32 here plus angle AOB is equal to what? 180 degrees. 32 plus 32, we are getting 64 plus angle AOB is equal to 180 degrees. Now we are looking for angle AOB. So we are getting 180 minus what? 64. And we are getting angle AOB to be 116. So it means that this very angle is 116. Now from here we can apply the theorem 2. The theorem 2, which says that an angle a chord subtends at the center of the circle is twice the angle subtends at the circumference. So if this angle is 116, our angle y is going to be 116 divided by 2, and that should give us what? 58. Very, very simple. Thanks for watching.